Slope. Slope is usually taught using one of these three formulas you see on the top here. Either rise over run in the middle, change in y over change in x on the right, or y2 minus y1 over x2 minus x1. They all mean the same thing. And to understand how you calculate slope, let's find the slope that would go through 2 points. The point 4, 3 and the point 1, 2. If we graph these out, 4, 3, 1, 2, 3, 4, 1, 2, 3. Here we have 4, 3, and x1, y2. Here is our 1, 2. The change in x, you can see, is how far it is from here to there. 1, 2, 3. Change in y, how far it is from here to there, and that's 1. Now, if you want to use the formula here to do it, you'll see the formula here is just a way of doing this without graphing it. Let's say that we'll use this point here as our x2 and our y2. We're then going to have 3 y2 minus y1, the 2 from the other point. Then on the bottom, x2, which is 4 minus 1, which simplifies to be 1 over 3. So you can use any of these formulas. Rise over run is just a way of graphically looking at it, and it means the same as the change in y over change in x, or the formula y2 minus y1 over x2 minus x1. So, the next question is, what if we decide to call this our x1 and our y1? Will we get the same slope of 1/3? Well, let's find out. That's going to make this x2 and this y2. So here we're going to have 2 minus 3 over 1 minus 4, which becomes negative 1 over negative 3. And if you remember, a negative over negative becomes a positive, or 1/3. So as you see, it doesn't matter which point you choose to be your x1 and y1. You can do either one. All that does matter is, if you're going to choose your y2 to be this 3 here, then the x2 has got to be the matching x value. Alright, so that was our first example of looking at slope. Let's now try to find slope applying our directly our formula, and let me get a clean. Okay, so let's try this all over again, just using the formula. Let's try to find the slope of the line through the point 1, 3 and negative 1, 2. All right. So we're not going to graph this. We're just going to directly apply our formula. Alright, so change in y is going to be 3 minus 2. Change in x, remember if we start with this 3 here, we have got to bring this 1. We've got to start with this 1 here. 1 minus negative 1, which will give you a 1 over 2. Again, you could have started with the negative 1 and the 2. I chose to start with the 1 and the 3. Either one will get you to the same 1/2. Okay, let's find the slope of a line through the points 3, 1 and 2, 4. So, step 1 is to write our formula. Slope equals y2 minus y1 over x2 minus x1. Some people like to write the x and the y over the 2 points to keep them straight. So y2 minus y1 is 4 minus 1 over x2 minus x1, 2 minus 3. 4 minus 1 is 3, 2 minus 3 is negative 1, or negative 3. Okay, so again, we could have switched these. We could have done 1 minus 4 over 3 minus 2, and either way, your final slope should simplify to be negative 3. Now let's look at two special cases of slope that students often encounter. They're important and they often trip up students, and we'll conclude the video tutorial with that. Let's find the slope of a line through the points 5, 7, and 5, -2, and then we'll look at the bottom question. Alright, well, let's just try to solve this like we normally would. Right? Slope is y2 minus y1. Let's label our x and y's, makes it a little easier. y2, -2 minus 7 over x2, 5 minus x1, 5. And you end up with -9 over 0. Now, if you remember your fractions, you remember that having a 0 on the bottom is a problem, and in fact, it leads to an undefined value. And in fact, the slope of any line, if you look at our axis, and let's kind of look at what this line would look like. What would a line look like that would go through these 2 points? Well, we would have x over at 5, 1, 2, 3, 4, 5, and it would go through both 5, 7, somewhere up here, and 5, -2. In fact, it would be a vertical line. My vertical line doesn't look so hot there, didn't get through the points, but hopefully you get the idea. A vertical line goes straight up and down, as you can see through the fact that its x value didn't change. It was 5 here, and it was still a 5 there. And that leads to a x2 minus x1 being 0. So any vertical line is going to have a slope of 0. So if I drew a vertical line at x equals -2 here, the slope is also undefined because you're going to have a change in x of 0. Alright, so just to summarize, the slope of any vertical line is undefined. Now let's look at the slope of a horizontal line, right? This one will turn out to be horizontal. So vertical is undefined. What do you think is going to be true about a horizontal line? Let's say we've got 1, 2, 3, 4, 5, 6, 7, 8, or wherever you are. What would the slope of that line be? Well, let's find it out by just trying to find the slope of a line through the points 4, 9, and 3, 9. And you'll see in a minute that this would be a horizontal line. Use our normal formula. We've got x and y. So it's y2 minus y1, or 9 minus 9, over x2 minus x1, 4 minus 3, or 0 over 9. And if you remember, this is another special situation for fractions. If you have a 0 on the top of a fraction, the fraction is 0. The entire value is 0. So the slope of a horizontal line is 0. And you can see what it would look like here. This is actually at y equals 8. But as you can see, in this, up on the vertical line, it was the x value that never changed, right? Slope is y2 minus y1 over x2 minus x1. Some people like to write that as delta y over delta x, change in y over change in x, or the rise over run, whatever you prefer. If it goes straight up and down, what isn't changing? The run. The delta x, the x2 minus x1, it's the same number, so you get a 0 on the bottom. However, if it's horizontal, the run changes, but as you can see, the y value doesn't change. The delta y doesn't change. The rise doesn't change, so you get a 0 on the top. So the slope of any horizontal line is 0. The slope of any vertical line is undefined. And that concludes the video tutorial on slope. Feel free to visit our website, mathwarehouse.com/slope, where you'll find a bunch of other goodies, including an interactive applet, a worksheet with an answer key, and many other practice problems. Thanks a lot.